Hmm.
Good morning. Myself, Samarendra Konda, lecturer in physics at Universal Institute of Science and Technology. Today we will study about electrostatics in Unit 3 in Applied Physics 2 of second semester. So first, what is charge? The charge is the property of matter due to which the electrostatic force of attraction or repulsion can be experienced. So charge is generally the property of what? There is so many properties of matter. So charge is among one of them. That is the property of matter due to which the electrostatic force can be experienced. And another one you can tell this: the electric field is the region around the charge, and the charge is the region because of which electric field can be experienced. Next, Coulomb's law. The Coulomb's law describes the force of attraction or repulsion between two charged bodies. So it generally states that the electrostatic force of attraction or repulsion between two charges or two charged bodies is directly proportional to the product of magnitude of their charges and inversely proportional to the square of distance between them. Okay. So let's suppose there are two charges, Q1 and Q2. Let Q1 and Q2 be the magnitude of these charges respectively, and they are separated by distance r. Okay. Now, according to Coulomb's law, okay, we have considered two charges Q1 and Q2 which are separated by distance r. Now, according to Coulomb's law, the electrostatic force of attraction or repulsion, that may be attractive force or repulsive force because of the nature of charges. You know, the like charges repel each other and unlike charges attract each other. That means if you bring together a positive charge and negative charge, they will attract each other. And if you bring together a negative charge and another negative charge, they will repel each other. In the same case will happen with the two positive charges. Now, according to Coulomb's law, the force of attraction or repulsion between two charges is directly proportional to product of their magnitudes. That means Q1 and Q2, and again inversely proportional to the square of distance between them. That means it is proportional to 1 by r square. Now we are combining the two things. So it is proportional to Q1 by r square. Now, we got this expression f is proportional to q1 q2 by r square. So it can be written as f is equal to k q1 q2 by r square. This is the required expression where k is the proportionality constant and it has a value. You can tell k is equal to 1 by 4 pi epsilon naught in SI system, which has the value is equal to 9 into 10 to the power 9 Newton per Coulomb square into meter square. So this can be written as F is equal to 1 by 4 pi epsilon naught q1 q2 by r square, or it is equal to 9 into 10 to the power 9 q1 q2 by r square. This is the final expression of the force between two charged or charged bodies. In vector form, we know there are three charges Q1 and Q2. The force between force is a vector quantity. It has both magnitude and direction. So there is two charges Q1 and Q2. The distance of separation or the displacement vector from Q1 to Q2 is taken as R12 vector. Then the distance from Q2 to Q1 is taken as R21. And F21 vector is the force applied by Q1 on charge Q. And here the force F12 vector is the force applied by the charge Q2 on charge Q1. Now let's write the force on the charge Q1 due to Q, that is F this 1 which is equal to 1 by 4 pi epsilon naught. The magnitude of two charges Q1 Q2 by R squared, that means R squared R vector squared is equal to R squared. Magnitude square the vector square that means square of this magnitude, that is R squared. And this is this has the direction, the force, that's why the direction can be taken here R21. R12 means it is the unit vector which has the magnitude 1 but direction in the direction of R21 vector. It can be written like this. R21 can, that means R21 vector and R21 vector magnitude. If you take magnitude from both sides, that will be 1 and that will be the same in denominator and numerator, that will be 1. Because for the direction purpose. Now the force on the charge Q2 due to Q1, this can be written as the force on the charge Q2 due to Q1, that is F12 in that direction. Here we have taken two like charges so that they are repelling each other. This charge repels this charge in the direction, and the Q1 charge repels to in that another direction, it's opposite direction, because they are like charges, they repel each other. Now F1 is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, and the direction in R1 vector R12 kept. So now we know from the property of vector, if the R12 vector and R21 vector, the two vectors are same in magnitude but they are opposite direction. So we can write R12 vector is not equal to R21 vector, because R12 vector equal to minus of R21 vector, and R12 cap is equal to minus of R21 cap. So we can use these things in these two equations, right? Write this equation 1, this is equation 2. So now applying the method, suppose we can take any of this. Suppose let's take this R21 cap. R21 cap is equal to, if R12 cap is equal to minus of R21, then R21 cap is equal to minus of R1. So let's write this 1 by 4 pi epsilon. Whenever writing this F12 is equal to 1 by 4 pi epsilon Q1 Q2 by R square. We are taking in place of R12 cap, that is minus of R12 cap. minus R12 cap. That is equal to minus 1 by 4 pi epsilon naught Q1 Q2 by R square R12 cap. And you can see 1 by 4 pi epsilon Q1 Q2 by R square R12 cap. Here minus 1 by 4 pi epsilon naught Q1 Q2 by R square R12 cap. So they are same in magnitude but opposite in direction. It can also be written as F minus 1 to 1 vector. So it can be written as F12 vector is equal to minus of F to 1. If you take magnitude in both sides, F12 vector equal to minus F1 vector. If you take magnitude in both sides, that's what that will be equal. That's it. And charge. The unit of charge is coulomb in SI unit, and the force unit of force is Newton. So how we get the unit of 1 by 4 pi epsilon? Now you know F is equal to 1 by 4 pi epsilon naught Q1 Q by R square. Here you know the 4 pi value of 4 pi. F is the force, Q1 and Q2 are the magnitude of charges, and R is the separation between charges, and epsilon is called permittivity. So this the value of this is equal to 9 into 10 to the power 9. 1 2 by R square. But if you